Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the October 2013 Grade 9-10 Contest Question 20, which also came up in the Grade 11-12 Contest. So the question is, suppose that the diagram is to be completed so that each white square contains a different whole number from 1 to 12 inclusive, and also so that the four numbers in the set of squares along each edge have the same total. In how many different ways can a diagram be completed correctly? So the question already states that each of the numbers from 1 to 12 occurs only once in the diagram. And it also requires us to know what the total of each of the four edges is. So now we can't just simply add up all the numbers from 1 to 12, because when you look at a corner number, so for example 5, it counts not only towards this edge, but also towards this edge. And the same would go for 12, since it's a corner number. 6 is also a corner number, and whatever number that is. So first, we would add up all the numbers from 1 to 12. So if you look over here, we have sum of boxes, and then we already have 1 plus 2 plus 3, all the way up to 12. So now the easiest way to do it would just be take the smallest and the largest, which is 1 plus 12, and then multiply that by the half of 12, which is 6. Now the reason why we can do this is because if you look, 1 plus 12 has the same sum as 2 plus 11, 3 plus 10, and so on. So we would have 6 pairs of 13, since 1 plus 12 is 13. So we would have 6 times 13. And that would equal 78. So, like I mentioned before, we would also have to add 5, 12, 6, and whatever number that is, one more time towards 78. So now we would look here, sum of four edges. So we know that we already have 78. And then we would have plus 5, plus 12, plus 6, and plus this, which we will call question mark for now. So 5 plus 12 is 17, plus 6 is 23, 78 plus 23 is 101. So the sum of the four edges would have to be 101 plus the question mark, whatever number this is. Okay, so now since we know that we want the total of the four edges, and we know that the total of each edge is the same, we know that the whole total of the four edges must be a multiple of 4. So we would look at the next multiple of 4 after 101. So the next one would be 104. So that is 3 more than 101. So that means that this number would have to be 3. But if you look, 3 is right there. And since we know that each number from 1 to 12 only occurs once, we know that it can't be 3. So then we would look at the next multiple of 4 after 104, which is 108. So then instead of this being 3, we would have it as being 7, since 3 plus 4 is 7. So now we would have 108, and we would divide that by 4, since 4 edges, and that would give us 27. So we know that each edge would total up to 27. So we have 7 plus 3 is 10, plus 5 is 12, 27 plus 5 is 15. So we have 27 minus 15 is 12. So that would mean that this number here would have to be 12. But if you look over here, we already have 12 here in this corner. So we know that it cannot be 12 here, and therefore 7 cannot be the mystery number, the number in this corner. Then we would look at the next multiple of 4 after 108, which is 112. So then that means that this number would have to be 11 because 7 plus 4 is 11. So also, we know that this number must be 11 because the option after that would be 4 more than 11, which is 15. But we know we can only have numbers that range from 1 to 12. So we know that the number in this corner must be 11. So now we would have 112. So the sum of the 4 edges is 112. So now we would do 112 divided by 4 because 4 edges, which is 28. So the total of each edge is 28. So we would have 11 plus 3 is 14, plus 5 is 19. So 28 minus 19 is 9. So also here we see that since we have 4 edges, we know that it must be 4 times 28 because the total of each edge is 28. So now let's look at the remaining 6 numbers. So now we would start from 1 and go to 12 and see what numbers we have left to fill in these 6 boxes. So let's start with 1. We don't have 1. 2, we don't have either. 3 is already here. 4, we don't have. 5 is already here. 6 is already here. 7, we don't have. 8, we don't have either. 9, we have. 10, we don't have. 11, we already have. And 12, we have. So we know the remaining 6 numbers, which we will fill in here, is 1, 2, 4, 7, 8, and 10. So now we know that each edge totals up to 28. So here we would do 11 plus 6 is 17. So 28 minus 17 is 11. So we know that these 2 numbers must add up to 11. Here we have 12 plus 16 is 18, and 28 minus 18 is 10. So these 2 numbers must add up to 10. And now finally here, on the last edge, 12 plus 5 is 17, 28 minus 17 is 11. So we know that these 2 numbers must add up to 11. Okay. So now let's look at pairs of numbers that would add up to 11. So 1 and 10 we know would add up to 11, but also 4 and 7. So let's start by just writing 1 and 10. Which means that 4 and 7 would have to go here. And then the 2 numbers that we have left is 2 and 8, which fits perfectly because they both add up to 10. So here we can see that this here is one possible answer because each of the numbers from 1 to 12 is only used up once, and each edge totals up to be the same. So now we have to look for more possible solutions. So if you look at these 2 numbers here, and also these 2, and these 2, we see that since these 2 numbers only count towards this edge, we know that we can interchange them. and the same goes for these two, and the same goes for these two. So since we would have each of these two options multiplied by each of these two options, which is 2 times 2 is 4, multiplied by each of these two options, which is 2, we would have 4 times 2 is 8. So we already have 8 possible solutions. But now if you look here, both of these numbers and both of these numbers must add up to 11. So we know that we could just put 1 and 10 here, and put 4 and 7 here, and we would do the exact same thing. So we would have each of these two options, multiplied by each of these two options, multiplied by each of these two options, which is 2 times 2 times 8. 2 is 8. So since we already have 8 from before, and we have 8 now, we know that 8 plus 8 is 16, so that there are 16 possible solutions. If you'd like to know more about this contest, please feel free to visit our website at www.brocky.ca/caribou.